You're probably starting to notice that we have a lot of theorems about polynomials, and here are two more. And they help us, if we know some of the zeros, sometimes then we'll have other zeros that we have to have. So if we have polynomials with real or rational coefficients, if a polynomial has real coefficients, so if all the coefficients are real numbers, then if a plus bi is a 0, so if we have a complex 0, then its conjugate also has to be a 0. Okay, so if you have one complex number, its conjugate also has to be a 0. And if you have rational coefficients, so if all the coefficients are rational numbers, then if you have something of the form a plus c times b of x, so if you've got a square root here, then you have to have its conjugate as well, just putting a minus before the square root. Okay, so number 1 here says a polynomial of degree 5 with rational coefficients has these zeros: 4, negative 3i, and 1 plus 2i. Find the other zeros. Okay, now, so we have 4. 4 is a rational number, not complex, doesn't have a square root. We're going to leave that alone. Then we see negative 3i. Now, negative 3i is a complex number, so we have to have its conjugate, which would be 3i. Then we have 1 plus the square root of 2, which has a square root, so we'd have to have its conjugate, which would be 1 minus the square root of 2. Okay? So very similar here. We have a polynomial of degree 6 with rational coefficients that has these zeros: negative 4 plus 3i, negative 7i, and 4 plus the square root of 2. Find the other zeros. So we just need to find those conjugates. So the conjugate of the first one would be negative 4 minus 3i. The conjugate of negative 7i is 7i. And the conjugate of 4 plus the square root of 2 would be 4 minus the square root of 2. So here you just have to remember, if you have a complex number or a number with a square root that's a 0, you have to have its conjugate as well.